2.2 on translations. And so your goal today is to take what we've done in class and to summarize what we've done so that you understand how to perform a translation transformation. All right, so like we've been experimenting with in class, what we're basically doing is sliding an object. So before we go any further, let's first talk about the entire chapter. This chapter is going to be a lot about geometric transformations. And a transformation is something that changes a figure into another figure. Oh, by the way, sorry about this particular slide. It's a little blurry because I cut and paste from a different, a low resolution picture. So hopefully make do with what you got here. But what it says is a transformation changes a figure into another figure. The new figure is called the image. So right here, there's an example of a translation. We've got the red image here. It's been slid and created a new image over here. Now, new image meaning that it's not in the same position. It's the exact identical congruent shape, but it's just in a new location. So a translation is a transformation in which a figure slides but doesn't turn. So notice that the only thing that has changed is the position. The orientation of the shape is the same, the size is the same. It's basically a congruent shape. And what we're going to really focus on is how to do this mathematically, and how what we're really doing is we're taking every point of the figure and we're moving it the same distance and same direction. So in other words, we took this top left corner, moved it a specific distance. Took the top right corner, moved it the same specific distance and same direction, and same thing with the other two corners. So you're going to see that in one of two ways. Here's one way. The vertices of a square are point A, 1, negative 2, and in fact I'm going to go ahead and place these. So 1, negative 2, there's A. B is 3, negative 2. So across to 3, down to negative 2. C is 3, negative 4. So 3, negative 4. And D is 1, negative 4. So across to 1, down to negative 4. And so you can see our square there. Our square, let me just resize this, would be right here. This is the original shape. Some books refer to it as the pre-image. All right, now what we're going to do is we're going to draw the same figure. Well, I'm sorry, we've drawn the figure. We're going to draw its image after a translation 4 units left and 6 units up. So this is one way you'll see a translation described, specifically just in words, telling you exactly what directions and how far to move. All right, so what we want to do is we basically want to take each of these 4 dots and apply this transformation. So I'm going to use blue for our image. So let's start with A. A was right here. And it said translate 4 units left, so 1, 2, 3, 4, and 6 units up. 1, 2, 3, 4, 5, 6. All right, and this is what we would call A prime. It's A prime would look something like this, where it's basically A with the little apostrophe. And that's a way to denote which one's the original A and which is the copy. All right, let's do the rest of them. So now we do B. B was 3, negative 2, which is right here. So again, we're going to apply the translation. Translate 4 units left to 4 right here. Did I do that right? 1, 2, 3, 4, and 6 units up. 1, 2, 3, 4, 5, 6. Okay, and this would be denoted as B prime. All right, and then we just keep doing the same thing to the rest of them. We now take C. C was 3, negative 4, this one right here. So again, 4 units to the left, 6 units up. There's C prime. And finally, we tackle D. D was this one. And apply the same translation. 4 units left, 6 units up, and there's D prime. And so that's how we describe a translation. We basically just give direction and distance, and then we take all the different points that make up that shape and just translate all those points to the new location. But what, like the definition said over here, is that the figure's been slid but has not been turned. Now it's hard to tell with the square, but in this case the square is still facing the same direction. This was the top here, this is still the top here. It would make more sense if we had a different shape where all the sides weren't the same to see that. All right, so that's a translation, just basically sliding a shape from one location to another. Now, here's another way we're going to see it, and we did this on SketchUp. A mathematical translation. So sometimes, rather than saying it in words, they'll give you the pre-image or the figure. Vertices of a triangle are a, -2, -2. Right there. 0 to +2, which is right here, and 3, 0. All right, so there's our triangle. If I go and get some lines, don't have the triangle ready to go, there's our triangle there. Okay, now what we want to do is apply this translation, but notice what's different. Instead of saying left or right or up or down, what they've done is they've shown it mathematically, and they're saying for each point, x and y, those coordinates, take x and add 3 to it. Take the y coordinate and subtract 2 to it. So what we get here is we basically take the original point, here's a, -2, -2, and we apply that mathematics to it. So -2 plus 3, you can see here in blue is the translation, -2 minus 2, which is from here. And then, so what we get is where a prime should go. A prime should be at the location 1, -4. So 1, -4. And this used to be this point. So it looks like what it did was the x plus 3 slid it to the right 3 spaces, which makes sense because the x coordinates control horizontal movement. And then it went down 2 spaces, and that makes sense also because the y coordinate, which controls vertical movement, it was -2, so it dropped it down 2 spaces. And so this is just a mathematical way of saying something similar as to what was said here in plain English. All right, well, let's do the rest. Let's take B, 0, 2. B is 0, 2. We apply the exact same transformation to it. 0 plus 3, 2 minus 2. The same thing we did to the first one. Notice how they're highlighted in blue. And so B prime becomes 3, 0. So across to 3, 0. Now, it's okay that it's one of the other original points. It just means that our two, our image and our pre-image are going to share a point. All right, so now let's apply this same transformation to C. C was 3, 0. We apply the transformation to it, which was to do 3 plus 3, which essentially moves the shape, the dot to the right 3 spaces, and then 0 minus 2, which moves the dot down 2 spaces, which gives us this. C prime should be at the location 6, -2. So 6, -2 would be right there. So if we've done this right and we join up the points, oops, use a line for that, look better. What we should have is the same exact triangle, same shape, same direction, but just a new location. It's been slid, but notice how it hasn't been turned, enlarged, shrunk. It's the same congruent figure. All right, so that's translations. It's basically sliding an object and doing it 2 different ways, either when the directions are given to you in words or when the instructions are given to you mathematically, and how we just do it by sliding the vertices and then just reconnecting them. And if we've done it right, we just get the same shape in a new location.